Alright, so today we're going over optimization problems. So essentially in this topic, what you're doing is you're basically optimizing a value for two variables that are given and unknown in the um, problem. So the most notable formula here is going to be A equals XY. That's, if that seems familiar, that's like that's the area formula of a rectangle. So let's say you want to optimize this and they say to find the value of x in which the product of this is like 100 or something. The a would be the 100. So what you would do is you can't find the derivative, or you don't want to find the derivative of two values. So what you have to do is plug in x for something in terms of y. So we would put the original equation in terms of x, that would give us x equals a over y, and that we would substitute that in for x. You'll see how this works later, and then you'll differentiate it and solve for y in order to find the y value, and then you'd find the x value by plugging into our original equation. So let's say we had x plus y equals 5. What you would do is the equation would be like find the value of x and y. You would plug in for y, you would plug in the equation in terms of x, and then you would just solve for x and find out x, and then plug it in, find out y. But for this, I mean, this equation is pretty easy. You could figure it out in your head, but as the equations get more complex, you do have to use optimization in order to find the answers. All right, so let's take a look at number two. So number two is find two numbers whose difference is 100 and whose product is a minimum. So we're gonna have x plus x minus y is going to be 100, and so we want to find x times y is going to be a minimum. That's what we want to find our answer as. So what could we do here? We want to have one variable here. So what we could do is use this original function to help us turn this into one variable. So we could set this in terms of x. So if we add a y on both sides, we're going to have x is equal to 1 plus 100, or 1 equals 100 plus y. And now what we could do is plug in that for x. So we're going to have 100 plus y times y and minimum. And you don't have to keep this minimum here, but just for visualization purposes. But now all we need to do is multiply out the y. We're going to have 100y plus y squared, and now just solve for y, and then we're going to solve for x after. So if we solve for y, we could subtract 100y on both sides, and we're going to have y squared is equal to negative 100y. Let's divide by y on both sides. So we're going to have y is going to be equal to negative 100. And now all we need to do is now find x. And so what we could do is plug it into original equation, x minus y equals 100. So we plug in negative 100 for y, we would have x plus 100 is 100, and x would be 0 in that case if we subtract 100 on both sides, so x would be 0. So now we plug it into original equation just to make sure. So we want to find a minimum product. So if we plug in 0 and negative 100, it would give us 0, so that our product is a minimum. So, 0 times negative 100 is going to be a minimum. And then if we plug it here, it's going to be 0 plus 100, which is also 100. So it follows both of these rules. So that would be our x and y values. All right, so let's move on to number three. So number three is find two positive numbers whose product is 100 and whose sum is a minimum. So we're going to write out the equations first. So find two positive numbers. Product has to be 100, and these numbers have to be positive. And the sum is going to be a minimum. So we have to figure that out. So using this here, we could turn this into a function in terms of y or x. So what we're going to do is we're going to divide by y on both sides. So we're going to have x is equal to 100 over y. Now we just plug in x into here. So we're going to have 100 over y plus y is going to be equal to a minimum. We're just going to leave nothing here. So what we're actually going to do is net minus y on both sides. So we're going to be left with here 100 over y is equal to negative y. And now we can just multiply by y on both sides. So we're going to have 100 is equal to negative y squared. And now if we know that if we plug in 10 or negative 10 into y, it's going to give us 100 squared. But we're looking for two positive numbers, so y has to equal 10 here. And now that we know since y is equal to 10, if we plug in y into 10 here, that means that x also has to equal 10. And 10 plus 10 is going to be 20. 20 is going to be our minimum, and y equals 10 and x equals 10 are going to be our answers. All right, now let's check out number 4. So number 4 is the sum of two positive numbers is 16. So we'll do x plus y is equal to 16. What is the smallest value of the sum of their squares? So that's going to be x squared plus y squared equals minimum. So what we're going to do here again is we're going to use this original function here and find it in terms of x or y. So we're going to have x is going to be equal to 16 minus x if we find it in terms of y. So now all we need to do is plug x for in here. So we're going to have 16 minus y is going to be into x squared plus y squared. And that's going to be equal to a minimum. So what we could do is we could actually multiply it out. We'll also move y squared to the other side. So we multiply it out and move y squared to the other side. We're going to have y squared minus 32y and plus 16 squared, which is going to be around 256. And that's going to be equal to negative y squared. So actually, we could bring over the y squared back to the other side. So we would have 2y squared minus 32y plus 256. So now that we've broken it up, we can actually factor out the 2. So we're going to have 2 times y squared minus 16y plus, that's going to be 128. So we can also factor this out in order to find y. So if we factor it all out, we're going to have y minus 8 squared plus 64. And now by this, this is all going to be equal to a minimum or a smallest value. We can see that y has to be equal to 8 in order for a minimum here, because you want this essentially to be 0, this over here squared to be 0. So we plug in 8, it's going to be 0. So 8 is going to be equal to y. And now in order to find x, we're just going to have to just plug in 8 into this equation. So we plug in 8 for y, it's going to be x plus 8 is 16, which is leaves x to be 8. So x and y are going to be 8, which means that the smallest value is going to be 8 squared plus 8 squared, which is 128. So that is the smallest value, and that is the x and y values. Alright, so let's take a look at number 11. So number 11 is consider the following problem. A farmer with 750 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with the fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? So what we know here, a known fact is going to be our perimeter, and which is the amount of fencing we have, and we need to figure out the area. So the area of a rectangle is going to be x times y, and let's also draw the picture here. So you want to enclose a rectangular area and then divide it into 4 sections. And yeah, that's going to be 4 sections. So x times y, let's say this is going to be x and this is going to be y. With that 750 feet of fencing, since we're also dividing into 4 pens, we're going to have multiple y's. And we're going to have 2 x's too over here. So that's going to be our perimeter. Our perimeter is going to be 5y plus 2x is going to be equal to 750 feet. So now all we need to do is just what we've done before is solve in terms of a variable and then plug it into here for the area. And then we could just solve for the area, largest possible area of the four pens. So if we do that, we're going to have, let's solve for y over here. So let's minus 2x on both sides. So we're going to have 5y is going to be equal to 750 minus 2x, and then divide by 5. So we're going to have y is equal to 150 minus 2 over 5x. Now all we need to do is plug in y for this. So we're going to have area is going to be equal to x times 150 minus 2 over 5x. If we multiply it out, we're going to have a is equal to 150x is minus 2 over 5x squared. And all we need to do now is just solve for x. So we could subtract 150x on both sides. And we could get rid of the a. It's not really, it was just placeholder. So we're going to have negative 150x is equal to 2 over 5x squared and negative 2 over 5. And we could cross out the negative since they're both negative. All right, now that we have this equation, we're going to solve for x, or no, we're gonna find derivative first, and then we're gonna solve for x. So if we differentiate this, we're gonna have 150 is equal to 4 over 5x. And now all we need to do is solve for x, so we multiply 5 on both sides. We're gonna have 750 is equal to 4x, and we divide by 4. We're gonna have x is equal to 187.5, I believe. Yeah. And now all we need to do is find y. So we plug in this into the original this known function that we have. So we got to plug in for y. So we have 5y is equal to 2 times 187.5, which is going to be 375, is equal to 750. So we can subtract by 375 on both sides, and we're going to have 5y is equal to 375. If we divide on both sides, we're going to have that y is equal to 75. And now all we need to do is plug it into the area. And if we plug in 75 times 187.5, we're going to have an area of about 14,062.5. And that is the largest possible area you could do with 700 feet of fencing. What that would look like in the little diagram we created would be that x over here would be equal to 187.5 and 187.5, and then all the y's would be 75, so we have 75, 75. Of course, if you didn't divide by 4, you would just have 2y, but now we have 5y because we divided this into 4 sections. So that would be the area, and this would be the y and x values. All right, so let's take a look at number 7. So number 7 is find the dimensions of a rectangle with a perimeter of 100 meters, area large as possible. So let's write what we know. So rectangle perimeter is of a rectangle is going to be 2x plus 2y is going to be 100. And the area is going to be x times y, which is going to be just large. We could just write large. So what we could do now is solve for a variable. So if we solve for x, we're going to have 2x is equal to 100 minus 2y. And let's divide by 2 on both sides. We're going to have x is equal to 50 minus y. And now let's plug that in for x. So we're going to have 50 minus y times y is going to be our large, or you could just leave it blank. So if we multiply that, we're going to have 50y minus y squared. is equal to large. It's a placeholder, it doesn't actually have value. But now all we need to do is plug in, or rather add y2 on both sides. So we're gonna have 50 minus y, or no, 50y is equal to y squared. And now we differentiate, so we're gonna have 50 is equal to 2y, which is finding a derivative. We divide by 2 on both sides. We get y is equal to 25. And now we need to find x, so we gotta plug into original equation. So we know y, so we have 2x plus 2y, which is going to be 50, is equal to 100, and that would mean that x is equal to 25. So x is also equal to 25, and that would give us the largest rectangle area, because 25 times 25 is going to be a very large number. It's going to be 625 meters squared. And that is our area as large as possible and the x and y values. All right, so I want you guys to try number 15. So this is essentially, they give you the values and I would suggest drawing a picture first and then answering it. So you could pause the video and try this question out. All right, so let's take a look at this question. So a farmer wants to fence in a rectangular plot of land adjacent to a north wall of his barn. No fencing is needed along the barn. The fencing along the west side of the plot is shared with the neighbor who has split the cost of the portion of the fence. The fencing cost is $20 per linear foot to install, and the farmer is not willing to spend more than 5,000. Find the dimensions. So let's first draw a picture so what we know what we're working with. So we're working with a rectangle that has no the north wall. It doesn't exist because that's going to be the wall of his barn. So we don't need to fence that. And the west side, we only need to fence since it's being split. We only need to technically fence half of it. So let's say this is y and this is x. That means this side has to be half of x. And we know fencing is $20 per foot. So let's create an equation first so that we could find out dimensions. And since we're also talking about area, the equation we don't know is going to be xy is equal to a. And this must be a maximum. So first let's create the equation. So we're going to have half times 20x. That's going to be this side. And then this side is going to be 20y. And then this last side is going to be 20x. And that's going to be equal to $5,000. And let's rewrite out this equation so we could combine like terms. So we're going to have half times 20 is 10. It's 10x plus 20x is going to be 30x plus 20y is going to be equal to 5,000. And now we want to find this in terms of one variable so that we can plug it into this area equation. So let's solve for x. So let's subtract 20y on both sides. So we're going to have 30x is equal to 5,000 minus 20y. And if we divide by 30 on both sides, we're going to be left with x is equal to 500 over 3 minus 2 over 3y. And now let's plug this into the area for x. So we're going to have 500 over 3, that 500 over 3 minus 2 over 3y, and times y is going to be equal to our area. If we multiply it out, we're going to have 500 over 3y minus 2 over 3y squared. And now let's move the y squared to the other side. So we're going to have 500 over 3y is equal to 2 over 3y squared. And first, before we find the derivative of this, we could take out the 3 on the denominator because they're both the same on both sides. So let's find the derivative of 500y is equal to 2y squared. The left side is going to be 500, the right side is going to be 4y. Now if we divide by 4, we're going to have y is equal to 125. So this over here is going to be 125 feet. Now we need to find x. So in order to find x, let's plug it into this equation right here. So if we plug in 125 for y, we're going to have 30x plus 125 times 20 is going to be 2,500 is equal to 5,000. And we could subtract 2,500 on both sides. So we're going to have 30x is equal to 2,500. And we could divide by 30 on both sides. So our final answer for x is going to be 250 over 3 feet. And so this question was asking for the dimensions, so we don't need to find the area. But if you want to find the area, just plug in 125 and 250 over 3 for the area, and you'll get the area. But the dimensions would be, this is 250 over 3. Dimensions would essentially be 250 over 3 feet by 125 feet. But just a visualization here, this fencing would be 125 feet. This would be 250 over 3. And this fencing on this side would be, that would be approximately 250 over 6 or 125 over 3. But that would essentially be the dimensions. And if you want to find out the cost, just plug in 20 into the x and y or multiply by 20 and you would get the cost. So that's it for number 15. That was basically it for optimization. So there are some few rules here, but essentially what you saw is that when we went from an area to a perimeter, we didn't find the derivative, we just solved for the variable. And when we went from the perimeter to the area, we just solved for, we did find the derivative after we plugged in the variable and multiplied it out before we solved for the variable. But so that's basically what you do for optimization, and then this is mostly just gonna be questions asking you for the largest or smallest area, or rather the dimensions. But yeah, a really important thing is to know how to visualize it and draw a picture of the question so that you don't end up making a mistake, and also knowing how to create your equation. So that's basically it.